Awesome. Hey everyone. So I think we're sort of figuring out what we're discussing today on the fly, but I think originally about a week ago, we wanted to spend some time discussing all the markets that we should be trying to build on top of the, primitives that are wells and tractor, i.e., markets for silo yield, rate swaps, fertilizer, etc. And I think that through those discussions, we sort of realized that it's probably necessary to talk about how Beanstalk native assets like pods, for example, should be traded, i.e., should they conform to existing ERC standards? Should we propose our own, etc. So I feel like Publius, you'd probably be a good candidate to better talk about what the problem is and what sort of trade-offs we should be taking into consideration.
Yeah, so, kind of first off, on the dev call last Thursday, it was brought to the community's attention that, Seaport recently introduced some sort of support for arbitrary orders through the use of zones. Now, the whole purpose behind Tractor, and Tractor was loosely based on Seaport in terms of, how orders are created and, generally how they're fulfilled. But, kind of the idea for Tractor was to be a fully arbitrary, off-chain order book with on-chain settlement. Now, the initial deployment of Seaport supported a subset of that functionality in the sense that it allowed arbitrary transfers of tokens between two parties, but didn't necessarily support arbitrary functionality. What arbitrary functionality would entail would be the ability to perform some sort of pipeline function call or function call to any other contract in the process of order fulfillment and target the output of that action to either the fulfiller or the offer creator. Now, it seems like in Seaport 1.2, they introduced this concept of custom zones. Zones being some, you specify an external contract as a zone and make some function call to that zone. Personally have not had time to really dig into the weeds of what's possible with Seaport zone system. But now there's version 1.4, so I'm sure there's been several iterations along the way, and kind of where this all, how this all relates to kind of what's going on is, if Seaport is sufficiently generalized enough to support, the majority of markets that, that it would be great to have built, in and around Beanstalk, then there's no need to create Tractor at all. If there's already a protocol that can do the functionality that is desired, no need to reinvent the wheel. The kind of limitation here is that Seaport only natively supports 3 different types of assets: ERC20, ERC721, and ERC1155. Given that pods and deposits do not currently implement any of those 3 ERC standards, it leaves kind of the community with a couple of options here. Option 1 is to, create some Seaport fork and, modularly add support for deposits and plots. Option 2 is to, somehow extend the interface for deposits and plots to, kind of adhere to ERC 1155, and therefore kind of allow Seaport to natively support these assets. Kind of the work required for both is probably similar in the sense that, custom code will need to be written in both cases, an audit will need to be performed in both cases, code review will need to be extensively performed in both cases, and when thinking, 2 to 3 years down the road, it probably makes more sense to, make deposits in plots adhere to the standards so that, custom functionality for, these two asset classes is never going to be required to be implemented going forward. For instance, Depot, has custom permit and transfer functions for plots and deposits. If plots and deposits adhere to the 1155 standard, then there'd be no need to add custom support for these. So in the long run, by standardizing Beanstalk's asset types, it will drastically reduce the amount of code that will need to be written anytime some sort of technology is built with the intention of having it support, transferring, or use of arbitrary on-chain value, specifically as it relates to Beanstalk. I guess, we'll pause here for any kind of questions and comments.
And could you give an example use case of what Tractor was intended to support that your original understanding of Seaport would not be able to?
Yes. So from my understanding, Seaport, kind of a Seaport order originally consisted of multiple transfers. It was, a list of transfers from the order creator to the order fulfiller, and a list of transfers from the order fulfiller to the order creator. There was some kind of predefined pricing function that, kind of was used to define the relationship between the amount that was fulfilled and the amount that was sent from the orderer. So it used some sort of proportional system to where if, you fulfilled 10% of the order, then 10% of the items got sent to you. Kind of the first problem is there's no kind of custom logic to kind of price the two assets. The second problem is, there seemed to be no way to have custom pricing for different order IDs or for different token IDs. For something like plots, where you can imagine the index of the plot is the token ID, there's no way to create some pricing function that's a function of that ID. Instead, when creating an order, you would just specify all of the acceptable IDs, store them, and put the Merkle root of that on chain, which means, there was no way to have the order priced on what the actual ID was. In addition, if there were any kind of, specific actions that were to be required in the order, perhaps, the person creating the order has deposited beans and the person fulfilling the order, or the order is denominated in beans, and therefore some sort of withdrawal is required to pre-pen the transfer of beans. I guess using pipeline, it could always happen after the order. But kind of there was no ability to perform some kind of arbitrary, on-chain action, to facilitate, in the middle of the order. Things like complex cancel conditions, where it's like you have, these 10 to 20 orders and you want 2 of them to be able to be fulfilled, or the sum of the amount fulfilled across all of them to be less than or equal to 1,000, say. These complex arbitrary conditions did not seem possible. Tractor, was going to be implemented, as basically a farm function to, either as a facet in Beanstalk and potentially as a standalone contract, where it just performs a list of on-chain function calls with the ability to kind of copy call data from, kind of the fulfiller's function call, the call data of the fulfiller's function call, and use that to populate the farm function call. So this farm function call becomes some sort of, composition of the data, that's originally created in the order and the data specified by the fulfiller. So, kind of by doing that, kind of it would allow, and the basic goal is, to allow something like a pipeline call to occur. If it's possible to perform some sort of call to pipeline, then it's probably possible to perform the majority of generalized on-chain, functionality. Think a really good example for where to kind of think of this, of what the original Seaport would not allow is, kind of in the case where there's some sort of, plots for deposits market. People want to, trade plots for deposits, and, someone wants to create some order where, any of their deposits is priced with some sort of y equals mx plus b formula where, x is the amount of grown stock, B is the price that they're using to price the BDV, and then X is the amount of, X is the amount of seasons or grown stock that has accrued on top of the deposit, and then M is the price of grown stock or the value of grown stock. And on the, they're trying to buy a plot and they want to use some complex, maybe the polynomial pricing function that was implemented for Pod Market v3. They want to use that in their order such that, only a plot that, is accepted by the pricing function, can be sold into the order, and the price at which it sells into the order is determined based on the return value of the pricing function. Now, in pipeline, how this would occur is, the fulfiller would specify the plot that they're trying to sell into the order when they go to fulfill the transaction. Now, in the order, there would be pre-encoded data specifying to copy the plot that was input by the fulfiller as call data into the pricing function and into the transfer function that is, encoded in the list of pumpkin calls or pipeline calls. I think I said pumpkin. I don't know where that came from. Pipeline calls that is originally specified by the order creator. So kind of the pricing function would be called with the plot input by the fulfiller. The pricing function would return. It would either revert if the plot was invalid or not in the specified range. Maybe the order creator only wants 500 mil or less in line, and it would return the price, which, pipeline using the advanced, call data functionality where it can, copy return values, would copy that return value, multiplied by some amount, into the transfer deposits function call. It would probably have to do a little bit of math to determine, price in the grown stock, et cetera, if desired, but maybe the grown stock's not priced. But the point is that, there's, the conditions which make this order valid are kind of sufficiently arbitrary. Now, kind of, this is where the open question is, like, could Seaport support an order of this type? And ultimately, the goal is to kind of try to first, determine whether that's the case. And if it is the case, then, that's great news. And, kind of then, kind of upon standardizing deposits and plots, they immediately have support for Seaport. Now, one more thing to note is that, also the question of whether farm balances can be used is an open question, but would imagine that kind of, through some sort of depot call where in depot you transfer, your farm balance beans to pipeline, and then pipeline fulfills the order through Seaport, it would still be possible to use farm balance in Seaport natively. So from that perspective, assuming Seaport is capable of doing that, which, it seems like might be the case. And, if it's not the case, it seems like their team has been iterating pretty quickly. They're already on Seaport 1.4, on trying to get to some generalized, logic structure for the Seaport order book. Benefits of using Seaport are, there already is great documentation on it. They already have an SDK, which could be leveraged, and there's already kind of a community of developers building in and around Seaport. So, kind of for Beanstalk to start from scratch in creating its own on-chain order fulfillment engine, even if it, is sufficiently or, substantially more simple in kind of the amount of parameters. Seaport seems to have a lot of fluff in terms of like optional the parameters that sometimes get used, but also has, sufficient, like a lot of different optimized gas efficient options for people only using a limited subset of the functionality. I mean, so does does that answer the question in terms of like what is the functionality that Tractor was intended to do that might be covered by Seaport?
It does. So what would be lost, or what would be the consequences of or the downsides rather of extending the interface for plots and deposits to fit into like 1155s that Seaport can trade?
Yeah, the biggest downside would probably be, gas considerations. When getting into the discussion of how to actually implement them, there are several design decisions to be made, which, kind of all impact the gas cost of, sowing, transferring, depositing, when the 1155 gets minted, etc. We'll get into that. Aside from gas cost, security concerns. Anytime the base, the core Beanstalk protocol is upgraded, there's, new potentially security vulnerabilities as there's new code being deployed on chain. Why this topic is, relatively urgent to discuss is that, currently there's a refactor going of the deposit system in Beanstalk, which, is a part of the whole variable seeds per BDV change. And, if the decision is made to migrate, to move deposits over to an ERC 1155 structure, it would be good to do that at the same time that the seeds per BDV change is done, to minimize the amount of times the silo needs to be upgraded overall. And just structurally, it would probably be, kind of a pretty significant change. So, when to group two significant changes into one would probably be ideal to minimize risk. I guess kind of implicate, but, other than potential security implications and increase gas cost, the user experience will probably not change, except for the fact that, now when you go to Etherscan, you'll see your deposits as 1155 tokens in your wallets and your plots, and you'll be able to use them on, OpenSea, presumably. However, one thing we'll get into is kind of like the arbitrary conditions around, that deposits and plots will need to be implemented in to support the 1155 standard might make it so that Seaport doesn't natively, won't natively work with deposits, but, that's something we'll get into later on in the discussion.
Do you mean Seaport or OpenSea at the very end there? That
Apologies,
OpenSea
OpenSea. Yes, OpenSea wouldn't support them. Maybe to get into why a little bit, kind of, let's take plots, as the example here, although for deposits, Again, something with several design considerations that can be made down the road. But on the plot side, it's plots are this ordinal structured asset where there are multiple pods in a plot, but those pods are numbered 1000, 1001, 1002, etc. They're not. If you have 1000 pods in a plot with an index of 1000, it's not 1000 at 1000. It's the ordinal. There's one pod at each number between 1000 and 2000. So when it comes to transfer, say you're transferring some of that, 1000, you're transferring some of that plot, we'll say 500. In the normal 1155 standard framework, one would expect the result of this transfer to be that I have 500 pods at index 1000, and you now have 500 pods at index 1000 because I transferred you 500 of my 1000 at 1000. That's the standard, implementation of transferring 1155 tokens. Now, plots, given its ordinality, would probably need some custom implementation of transfer from that includes the extra parameters that are currently included in the transfer plot function. Namely, the start and end range of the pods that are wanting to transfer. Now, fortunately, the transfer from function in ERC 1155 includes this extra parameter that can be used to input arbitrary call data into the transfer from function. So, quickly gonna paste the function signature in Barnyard chat. Give me a quick second just so everybody can look at this. And it might be helpful for people to actually, open the standard up as we're kind of talking through this. So the safe transfer from function, I'm going to post that here, kind of as specified, kind of has this extra data parameter. And so kind of what that means is that, kind of if plots implemented the transfer, 1155 standard, the start and end parameter could be encoded and passed into the safe transfer from function in this data parameter. And the implementation of the safe transfer from function, knowing this is the plots 1155 standard contract, would know to decode that call data into the start and end parameter and then transfer the correct amount. Now, kind of, I guess the second caveat worth mentioning here is, whereas the normal functionality from an event perspective is, again, going back to the example of how it works normally, I have 1000 at ID 1000, I transfer you 500. The event would be, emit transfer, from me to you with this ID amount 500. In the case of a plot, not only do you have to use this custom, call data to, in the transfer from function call, but the corresponding events that are going to be emitted are likely instead of this single transfer from event, it's going to be 3 events that are probably first burning the plot I have, burning 1000 at 1000, and then minting, whatever range to you that I sent, and then minting the rest of the plot to me. So say I sent you the first 500, it would either be and I guess this is another topic for discussion, but it would either be a transfer 500 at 1000 from me to you, burn the other 500, but probably what makes the most sense is to just have a burn, transfer to the 0 address 1000 at 1000, mint to you 500 at 1000, mint to me 500 at 1500. Just so it's clear, that I now have 500 at 1500 and you now have 500 at 1000. But kind of the point is the standard kind of one transfer event per transferred would be broken here. Now, upon reading through this 1155 standard, from my perspective, it doesn't seem like imposing these two kind of custom implementations of 1155 break the standard. But if anyone sees verbiage in here that would specify otherwise, please feel free to bring it up and share. As there's kind of quite a lot of conditions and rules in this standard. But I guess getting back to the point from OpenSea's perspective, it is my assumption that OpenSea is not going to know that it is required to enter this custom call data when transferring a plot NFT. So the plot NFT contract would probably, I guess, transfer the whole thing. I mean, there'll probably be some unique specific logic in the case. I mean, I guess it's like there could be some unique specific logic in the case where no call data is specified. And maybe that's, just transfer pods from either the beginning or end of the plot such that, because OpenSea by default, say you list, some pods on OpenSea, 1000 at index 1000, OpenSea is not going to know how to set that call data to specify the start and end range. As OpenSea, just assumes this is some generic 1155 standard contract. But I guess, to the point where there could be some default functionality implemented if no call data is specified, such that there'll still be some ability to support plots, on OpenSea. So from that perspective, I guess OpenSea would support limited functionality in a sense that, it would support either transferring the start or end of the plot. But, with plots, we already have the ability to do very simple orders through the pod marketplace. So, don't think that's that big of a deal. On the deposit side, there is definitely a bigger open question. And, that goes back to the question of, how are deposits ultimately stored on chain? And I guess, or maybe perhaps before we get into deposits, any questions, comments, thoughts kind of on plots, confusion around this implementation, thoughts on whether it fits into the specification, and thoughts on kind of how OpenSea is going to behave with this kind of, implementation.
I guess I'm a little bit confused on the, you mentioned encoding in the call data, like the start and end of the plot. I'm not totally sure a question to ask, but I guess my question is like, who or what is responsible for decoding that? And if you're using an interface like OpenSea, like how would you, as the Beanstalk DAO, how would we get OpenSea to interpret that data properly?
Yeah, so the decoding happens on chain. The implementation of the safe transfer from function will know to assume certain things around the call data. For instance, that it consists of two uints, adjacently encoded next to each other. The first one specifying start, the first one specifying end. So what the implementation will look like is, we might have, as stated, or it might make sense to add some default functionality in the case where no call data is entered or encoded into the function call. But in the case where call data is, it will first try to decode that call data into two integers. The start and end parameter or the start and length parameter, doesn't matter, they're the same. And then it will basically perform the same logic as the current transfer plot function using the ID, the amount, and then the start and end parameter. If the decode fails, meaning it's not the correct length, it's not the correct format, then the function call fails, which is the expected behavior as the entered information is false. So from the decoding perspective, that happens on chain. As you know, kind of the blockchain needs to know which part of the plot to send you. The encoding happens off chain, and that's where things get a little more complicated from a sense that, you know, OpenSea, to use OpenSea, will need to know how to encode the data to call the transfer from function with. And, you know, kind of that will, I mean, it probably won't be possible to get OpenSea to support, you know, transferring parts of plots. You know, kind of, it would require, you know, some sort of custom logic specifically for the plot 1155 contract. Now, my guess would be that OpenSea probably doesn't support anything like this, as, you know, they're focused on supporting, you know, the general standards, probably not focused on specific unique implementations. To my knowledge, OpenSea's UI is not open source, could be wrong there. If it is open source, then, you know, potentially it might be possible to submit some sort of pull request. But, you know, in general, to me at least, the important part is that Seaport supports the you know, the implementation and not necessarily OpenSea. As OpenSea is, you know, some short-term benefit in the fact that, you know, we've seen, you know, some volume for fertilizer on OpenSea, but, you know, there already is a pod marketplace supported within Beanstalk. And, you know, ultimately the intention will be to create, you know, a new pod marketplace more complicated than anything OpenSea could support natively. And at that point, using OpenSea at all becomes kind of, you know, a functionality reduction.
This might just be on my end, but sort of feels like we're using pods and plots somewhat interchangeably. And I remember whenever, you know, you would answer questions, you know, in the earlier days of Beanstalk about why pods or plots weren't implemented as, you know, either a 721 or 1155. And if I remember correctly, it had something to do with, you know, if plots were implemented that way, that, you know, liquidity would be reduced, given that they couldn't be split up. Maybe you already covered this to some extent, but any color there would be helpful.
Yeah, I mean, you know, just quite frankly, when Beanstalk was being developed, you know, there wasn't too much, you know, information or thought around, you know, kind of what standard interfaces exist, and, you know, what the specifications are to leverage and use the different standards. You know, when Beanstalk was being developed, DeFi as a whole was still relatively in its infantile stage, and, you know, kind of the importance of ERC standards in composability wasn't quite apparent to us at the time. And, you know, it's taken kind of a fair amount of research and reasoning to get to a place where it seems like it might be possible to implement plots and deposits. But, you know, kind of, so I guess the point is, like, initially, you know, when Beanstalk was first being developed, you know, it was first off not clear what the advantages to using ERC standards are, and secondly, it wasn't clear how to implement them as standards, you know, given the nature of plots and deposits. And, you know, one thing that's worth mentioning is, you know, there is the alternative solution, and this is ultimately something that the community will kind of need to come together to make a decision on. But there's the alternative solution in trying to create new custom value standards, you know, that become EIPs or ERCs at the Ethereum level, which are intended to be used for something like an ordinal token like plots. However, there's this kind of eternal question of, kind of when it makes sense to do it yourself. I think the Beanstalk community has seen firsthand, kind of how hard it is to build, create, and iterate on new things that are built from scratch, and kind of to create some new value standard in specifically intended to be used for ordinal tokens like plots. Kind of getting adoption of the EIP would be quite a significant task with a lot of overhead. Let's assume that 2 to 3 weeks are spent drafting some sort of EIP for this. How long will it take to get Seaport to support this new value standard EIP? How will kind of a community form around it? How will attention be given to it? Kind of only because it's been it's clear now that there's a need to kind of have deposits in pods kind of conform to a value standard, and that doing so is a step forward in kind of the spirit of composability on chain. Does it really seem like we're at a crossroads here where kind of support across DeFi for Beanstalk's native value is becoming a limitation in kind of way in use cases across DeFi? Hopefully that answers your question.
That's very helpful. Thanks.
Could you talk about the landscape of adoption of the 1155 standard across DeFi at the moment, particularly in the EVM?
Yeah, not entirely sure what you mean by landscape, but kind of,
like by DEXs and lending protocols. So OpenSea is an off-chain order book. They support the 1155 standard. But what about on-chain DEXs, and what about on-chain oracles, and what about on-chain borrow lend protocols?
Yeah, I mean, personally, not to, haven't had too much time to look deeply into kind of, the NFT ecosystem in general. But from, what I've seen, general lending and DEX support might be lagging a little bit behind. However, it's like the power of Seaport alone, is enough to kind of perform arbitrary trades and on-chain actions. And from my perspective, leveraging Seaport is definitely the biggest value add of adhering to such a standard. From a DEX perspective, an on-chain DEX perspective, maybe, believe that SudoSwap might have some sort of ERC 1155 pool structure, but kind of the current problem with most implementations of lending and borrowing protocols around these standards, as most of them make the assumption, or perform, allow for fungible and composable lending, borrowing, or pooling of these tokens by making the assumption that all the tokens within the standard or within the contract are similar in nature. For instance, I believe the SudoSwap pool assumes that all NFTs are basically the same and supports the ability to kind of sell or buy any NFT into the collection. So it really just becomes a means of trading the floor price, which is incredibly it doesn't help us at all when it comes to something like plots or deposits, where now we're looking at kind of tokens that are actually have some some independent variable on which they are kind of non-fungibly tokenized, to where it's like to put any deposit if you create some deposit mechanism for a pseudo-swap AMM, it's like, now you're grouping unripe Bean3 curve deposits with Bean deposits with Bean3 curve deposits. And, it doesn't seem like, and please, if something like this exists, please feel free to, shout it out or share it with the community here. But it doesn't seem like there's any like on-chain pricing mechanisms that allow for some sort of AMM to be deployed, taking in where it uses the ID of the collection as some sort in some sort of pricing function. From the lending borrowing perspective, I know there are a few out there. I don't think any of them are substantially have gained too much traction. But from my understanding, it also performs a kind of similar, or behaves similarly, also on the Oracle side, to where it really just allows you to borrow and lend at the floor price of the entire collection, and the Oracle is just providing the floor price. And when getting into these financial NFTs, where it's like the independent variable is actually something substantive instead of just like, some variation of the same PFP, kind of these existing platforms, don't seem to be able to be leveraged. Just, I guess, a note around the different standards going forward is that, at some point, it's going to make sense to kind of start building composable technology that potentially can support any of these value standards, and potentially any new ones. And, ultimately, it will be the goal for, Wells and, any, lending protocol that gets built to be able to support all three types of value standards. And, having some sort of defined, like, here are the bounds of, kind of storage space and, definition space for which all different types of values can be encompassed. And then, kind of composing those into a single kind of option where it's like within a well, you specify the token address and the type of value standard that token address is. So you can have an ERC against an 1155 token, and there's some kind of abstract, arbitrary conditions by which, ERC 20 tokens and 1155 tokens get exchanged. But, that becomes really quite difficult as, especially with the 1155 standard, there are kind of there's like an arbitrary number of accesses and, implications of those accesses that kind of need to be kept in mind when developing some sort of pricing function on top of them. So, kind of doing anything beyond kind of the turning the non-fungible into fungible, which is kind of what existing NFT borrowing and lending platforms and AMMs do, essentially reducing a 721 to an ERC20 or an 1155 to an ERC20, and just having some sort of interface that allows for that to happen. Kind of composing beyond that, well, still being able to use the fact that the orders are stored on chain, as an oracle, as, a tool to prove that, you have an open order, or a tool to liquidate into, becomes kind of difficult.
Thank you. But to the extent that any DEXs or borrow lend protocols are going to support 1155s in the near future, having pods and deposits support 1155 would maybe make it such that they can be used on those DEXs, and if not on those DEX UIs, at least at the contract level. Is that right?
Certainly.
All right. So you want to talk about deposits, or do people have more questions about pods?
When you talk about the urgency with regards to the variable seeds per BDV change? Is that entirely around any design changes to how deposits are structured? Or sorry, my question is that only involved with coming to a decision around how those deposits conform to 1155s, or are plots like a totally separate thing?
So in this case, it would specifically be for deposits. However, taking plots into kind of the context of deposits, is important from the perspective of kind of which contracts are responsible for being the 1155 contracts themselves. There are kind of three, or I guess four different options here, where for both pods and deposits, they can be implemented in a way such that Beanstalk is the 1155 token, or some new contract is deployed as the 1155 token. The four options being both pods and deposits are combined into a single 1155 implementation under the Beanstalk contract. This one is probably going to be the most complex and convoluted, but is going to be the cheapest from a gas perspective. Then there's the option of leaving Beanstalk as either pods or deposits as an 1155 and having the other one be its own contract. So those are options 2 and 3. And then there's option 4, in which both plots and deposits are their own 1155 contract. And I guess to kind of maybe help clarify what the difference is, currently right now, fertilizer is its own 1155 contract. To transfer fertilizer to fetch your balance, you call the fertilizer contract. When fertilizer's minted or transferred, the fertilizer contract emits the event. Beanstalk, every contract is capable of implementing each ERC standard once. So Beanstalk as a contract could be upgraded to be an ERC 1155 token. It could be upgraded to be an ERC 20 token. It could be upgraded to be an ERC 1155 token. It could upgrade to be an instance of all three of them. Now, what that looks like for Beanstalk to be two different ERC 20 tokens, two different ERC 1155 tokens is kind of the same as if it is to be one. It has kind of a domain space of 2 to the 256 potential IDs that can be used. And so long as pods and deposits are implemented in a way such that there can be assumed to be no collisions, then then there's some kind of graceful way that the Beanstalk contract can be both. What this would look like is probably in the transfer function. In the transfer from function, there'll probably need to be some Boolean flag that specifies, is this a plot or a deposit transfer? And based on that flag, that gets encoded into like the arbitrary data parameter. You call the transfer from function. The first thing it does is decode the call data to determine if it's a plot or a deposit transfer by just decoding the first byte or whatever, or the first bit, and then either going to the transfer plot function or the transfer deposit function based on that byte. From a gas cost perspective, there are several implications in both cases or design decisions that need to be made. If they were to be moved into a separate contract, and the biggest of which is just that the state of deposits and plots is currently stored within Beanstalk. So to move plots to some external separate contract, say that decision is made to have a separate contract be the plot 1155 contract or pod. Then the decision comes, should all plots going forward be stored in the state of that external contract, or should they still be stored in the state of Beanstalk? And when you call the balance of function on the plot contract, it just calls the plot function, the get plot function from Beanstalk. So it just becomes a wrapper contract in a sense that it emits the 1155 transfer and mint and burn events, but the state is stored in Beanstalk. The alternative being the state is actually stored in the plot contract for all new plots minted going forward, and there's some option to migrate existing plots into the 1155 structure, and potentially some option overall. So you can have some option to have plots that are not 1155s or plots that are. The exact same case is true for deposits. Kind of all deposits are currently stored within Beanstalk. So if the decision to make deposits a separate 1155 contract is made, then the consideration about whether to store that state in Beanstalk or in that 1155 contract going forward will need to be made. Definitely, and kind of thinking about the gas considerations of kind of the different options here. The gas cost of calling a separate contract is, the first time is 2,600 gas. So kind of in moving deposits and plots to a separate contract as an 1155 token, one can expect the gas cost to rise by at least 2,600, probably, something, probably add an extra 1,000 gas of general overhead. Now, and if the state is kept in Beanstalk, when you call the transfer from function, the transfer from function is going to have to call Beanstalk. So there's also going to have to be an increased gas cost of 2,600 on transfer if the state is kept within Beanstalk. Now, if the state is migrated to the separate plots contract, meaning a separate plots contract is used for an 1155, the state is moved there, then on transfer, the plot contract doesn't need to call Beanstalk at all. So they can kind of have a cheap transfer, but on mint, it'll still need that cross-contract call. Probably for simplicity's sake, it makes sense to leave, all state where it is and not move the state. Think the extra gas cost if the decision is made to use separate contracts is, probably worth it of, the fact that a call to Beanstalk will be necessary in the case of a transfer. But, just trying to first help define the kind of decision space on what the possible options are when discussing the details of potential implementations here.
Got it. So you feel like these decisions should be made at the same time, basically?
Well, they kind of need to be, kind of, because when, so let's say, a decision is made, namely the one that seems to be more urgent is on the deposit side, as, it would be great to kind of group those changes with the changes that Pizza Man's working on. If the decision to make, at the point where so the first question is then, is this a new contract as an 1155, or is it going to, is Beanstalk becoming an 1155? The second question is, if it's a separate contract, is the state going to be moved into the 1155 or kept in Beanstalk? Again, on this end, probably makes sense to leave the state in Beanstalk just for complexity's sake. There's a lot of state intertwined and wrapped specifically around deposits in Beanstalk. On the plot side, the optionality or the question is probably a little bit more open to where it's like, the plots, state is much more simple in the sense that there's never been a migration. They're not wrapped up in this stock and seed stuff. as, when you transfer a deposit, you're also transferring stock and seeds. The decision there might, it might make sense to move that state to a separate contract. But, just in general, any sort of migration, migrations are probably the most risky from a security perspective and, require the most amount of attention to detail and testing as, migrating every single state is, quite risky. So.
Great. Yeah, that answers my question. So maybe to Publius's earlier point, we can move on to deposits unless anyone has any other questions.
Gonna go ahead and move forward, but feel free to just cut me off or, if there are any more issues to address on that topic. So with deposits, the first thing that's important to do is define the domain space of, all of the unique identifiers for any type of deposit. Now, currently within Beanstalk, deposits are indexed based on two different variables. The first being token ID or token address, and the second being season. In this migration to the cumulative, to the variable seeds per BDV change, the index will change from a season to some, cumulative accrued grown stock per BDV index. But, the general idea is that, there is some, address, some token address, which specifies what type of deposit it is. And then there's some, index or, which defines, how much grown stock has accrued on top of the deposit. Now, one thing that's important to note is, any implementation, any implementation that deposits uses should be future-proofed. It's kind of an inevitability that Beanstalk will at some point need to support 1155s and 721s in the silo as whitelisted tokens. Let's take the case of, Uniswap v3 being whitelisted into the silo, and or some Wells v2 that has, some sort of ranged liquidity, maybe one-sided on-chain orders, maybe stop losses, whatever it be. In the case where there exists an AMM where there is more than one type of order, which is, every AMM but the Uniswap v2s and associated forks and versions, the constant function AMMs, if there's more than one way an order can be represented, then the ERC20 token immediately becomes an insufficient value standard to represent the liquidity position. This is ultimately what led Uniswap v3 to mint range liquidity positions as NFTs, and Trader Joe v2 to implement them as 1155s. Now, with this extension to 1155s, the domain space of deposits grows quite substantially from being just a token address, which is 20 bytes, plus some index, which currently is 16 bytes, but could be compressed if necessary. Why that's relevant is it could be compressed to 12, and 12 plus 20 is 32, and the domain space of an 1155 is 32 bytes. So if the domain space only is limited to that of ERC20 tokens, we could just compress that and make that the token ID, the address concatenated with this, the grown stock index. However, given the goal should be to future-proof things for instances where 1155s and NFTs are included, as discussed, the domain space of an 1155 and an NFT is 32 bytes. So even if, the grown stock index is compressed from 16 bytes to 12, we're still dealing with a minimum domain space of 64 bytes. as we have the token address plus the grown stock index plus the token ID. Now, obviously, the 1155 standard is that now we're trying to, so now we have 62, domain space of 62 bytes for the unique identifier for a deposit. And the goal is to squeeze that into 32 bytes, which is the limit of the NFT or the 1155 standard. Now, this is where we get into the discussion of, creating some value standard that has a variable length domain space or an infinite length domain space is one that becomes particularly interesting, as there isn't this requirement to try to compress the domain space. However, fortunately, cryptography gives us a very easy way to compress domain space in hashing. By performing, kind of common hash, standard hash algorithms, in the case of the EVM, generally Kekek is used, can compress arbitrary length data into fixed length. So given that there's no way to compress the domain space, naturally into 32 bytes, the next best solution is to hash it. So now let's say we take the token address concatenated with the grown stock ID, concatenated with the token ID, and we just hash that, resulting in the domain space of 32 bytes. Great, fantastic. Now now we're in the domain space of 32 bytes, the tolerable range for an 1155, and great, fantastic. Now the difficulty with hashing is kind of a one-way operation. When you have a hash, there's no way to determine what the inputs into the hash are. It's one way in the sense that, you hash the bean address concatenated by some ID, let's say 1,000,000. You're now given some random string of digits. The beauty of hashing is, the assumption of collision resistance is made, which is what allows us to kind of perform store, a larger set of data as a smaller set of data. But the problem becomes when I call balance of, if we look at this, I guess it's like, so ultimately the question becomes, how do we maintain the relation from, this 1155 ID, which is this hash, to the actual metadata of the token. And when I say metadata here, I'm referring to the 1155 metadata, which is if deposits are implemented as 1155, the metadata is the token ID, the grown stock index, and the token address. The token address, the grown stock index, and the token ID is the order we've been using. So now the question becomes, in the case of balance, how do you implement a balance of and a transfer function on top of this? Given that specifically, for balance of, the requirement is to query by the hash token ID. Kind of implementing that is simpler as, switching from an indexing system where we index from token ID to grown stock index to amount and BDV, just changing that to be an index from, hashed ID to amount and BDV will allow the balance of function to determine what the amount the user has deposited is. On the transfer side, and I guess, maybe to take a step back, and it's like, okay, so again, the goal is to be able to somehow define this relation from hashed ID to metadata. Specifically in the case of the transfer from function. As the transfer from function, you're calling transfer from with an ID that is hashed, and now this transfer from function needs to know how much stock in seeds to remove accordingly and how much to decrement your balance of BDV by. Now, the simplest way is to store that on chain. Every time some new ID is hashed or minted, there's some storage variable that's set in some mapping from token ID to token address, grown stock season, and this optional token ID. Now that's all fine and dandy, but the cost of on-chain storage is quite high. Each individual slot is 32 bytes, and cost around 22K gas to set. This means that every time a new deposit occurs, we're looking at least an increased gas cost of 20K gas to set that metadata. Because remember, the metadata for ERC20 tokens, let's say it can be comprised of 32 bytes, and for NFTs, it's 64 bytes. So in the case where each new unique ERC20 deposit is going to increase gas costs by 22K, and each new NFT is going to increase gas costs by double that, as it needs 64 bytes. Now, this is kind of the base case, right? So, and it's one option. So option one here is, store the metadata on chain. Fantastic. Increasing the gas cost of probably every deposit. Now, the alternative is to not store the metadata on chain. The metadata is already emitted through an event in the add deposit event. So by kind of linking the add deposit event to the transfer mint event, a mint event is just the transfer event where the from address is the zero event address. By performing some off-chain linking of token ID through to metadata by parsing events, we can define the relation from metadata to hashed ID. And in the case of the balance of function, so long as things are indexed on chain by hashed ID, the balance of function should be able to return a proper value. As far as the deposit function goes, the get deposit function, the withdraw function, these functions already take in the metadata. And from the metadata, it's very easy to generate the hashed ID. So no functionality needs to change from the perspective of the silo, other than storing in this index of hashed ID instead of token address to grown stock index to amount or whatever. Now the transfer from function, very similarly to the plot situation, can leverage the generic or the abstract call data bytes, data that can be input into the safe transfer function, that place where start and end were going to be specified for the plot implementation. In the deposit implementation, a deposit 1155 contract can mandate that the metadata is actually encoded in that data, and it can verify that metadata is correct by first decoding that data into token address, grown stock index, and optionally token ID, and then hashing that, verifying that matches the ID the user put in, and then proceeding with the transfer. So if this highly custom implementation is used for deposits that would break native compatibility with other UIs that don't support custom 1155s that take advantage of this data field, there is a way to implement deposits as 1155s without requiring any sort of metadata to be stored on chain. So within the deposit 1155 space, first question is, does this hashing the metadata and using the hash as the ID of the token, does that seem sound? Secondly, should it be a new contract, the deposit 1155, or should it be Beanstalk? And then the third question is, should the metadata be should the metadata be stored on chain, increasing the gas cost for all depositors? Or should it be assumed that the metadata is computed off chain using events and input into the safe transfer function as generic call data?
So did you say that the hash would be based on the token address, the Grunstock index, and then also the token ID?
Yes, and the token ID would only be for 1155s and 721s. Currently, there's no support for 1155s and 721s in the silo, so this would just be some sort of future proofing. Kind of to when 1155s and 721s are added to the silo, there already is some specification for how they can be incorporated into the existing, token standard.
So if we each deposited 10 Bean at the same time in the same season, wouldn't that give us the same hash?
Yes. So yeah, in the instance where two people, yes, exactly. But that's that's exactly as is the case with the current deposit function. Right.
Oh, but that hash doesn't make my 1155 or whatever it is unique. Like I'll still get, you and I will each get our own 1155 token or whatever it is. It will just have the same hash.
Yes, and because it is the same token and the same Grunstock index, they are the same in nature, right?
Yeah, cool. Got it. So are you thinking that this change should happen now before the Grunstock index modification is deployed?
So the big change to the actual implementation is the way deposits are indexed. Looking at this 1155 standard, need to pull it up again real quick. As far as I'm aware, the balance of function does not support that same generic bytes. Doesn't have that space to include the generic bytes. So, what's important is that by calling balance of with just the hashed ID, Beanstalk is able to determine how much of the token a user has. So what this means is, currently in the silo, deposits are stored in this mapping from token address to Grunstock index to deposit, right? What this change would require is that indexing system changes to just be hashed ID to deposit, such that the balance of function, by only knowing the ID, is able to retrieve the deposit. That makes sense?
Yeah, it does. So, but you're still thinking that this change should happen before any kind of Silo v3 migration, so that it's migration?
Yeah, it's like, this in the Silo v3, we're already changing the indexing system and adding legacy support for the previous indexing system. And to later on change the indexing system again is only going to add like another layer of, legacy support. So if the indexing system is already changing, it's probably a good idea to change now to at least the new indexing system, such that there isn't the requirement to move to a new indexing system again in the future. And kind of changing the indexing system is just every time a deposit is accessed or stored in storage, it takes the hash of the token address Grunstock ID and stores it at that hash instead of storing it directly in that mapping. Right.
Yeah.
From your perspective, does that seem like a reasonable thing to expect? Does it seem like a pretty significant change, or do you think it would be pretty easy to kind of sub out that indexing system?
Yeah, I would have to think through it a bit more. Just trying to think what other downstream effects it might have. Like, now in the UI, you can see what seasons you deposited in, which in theory we should be able to still get that data based on the events that are emitted. Um, but anyway, now it's going to be changing to the grown stock index at which you deposited. Just the only problem is from this hashed ID, we're going to have to make sure that you can always get out the three inputs, like the address, the grown stock index, and the token ID. So does that mean that it's always going to rely on the UI to input those? So for example, let's say I wanted to do a convert. For the convert, I would need to know, that the address of the token of my deposit, the index at which it was deposited, and then also the token ID, I guess. So the UI is going to have to input those every single time you want to do kind of any interaction with the silo, which should be fine as long as that data is available through events that were emitted.
Totally. And, that's a great point, Pete, man. Thank you for bringing that up. But isn't that how Beanstalk currently works, right? When you deposit, you give it the token address and the grown stock index. From my perspective, with this change, nothing about the interface or any of the existing function signatures have to change at all. This is only for a couple new functions, namely the balance of and corresponding balance of batch, safe transfer from and safe transfer from batch. And the existing deposit function doesn't even need to know what that indexed, what the hashed ID is. It can still take in the token address and the grown stock index.
Yeah, so basically any interaction with the silo is going to have to perform this hash every single time to make sure that the input data is indeed valid. Is that a significant gas cost, or is it pretty cheap to do that hash?
So hashing with SHA or Kekek is actually cheaper than you might think. I'm quickly pulling it up, but just for your reference, every time you use a mapping, it hashes the ID and it hashes the storage slot concatenated, the storage slot that mapping exists in, concatenated with the ID that is input. So the mapping is already performing a Kekek operation and maybe two because it is, too deep in the mapping. But just quickly pulling up the Ethereum yellow paper here so I'm not wrong. But a cost of a Kekek operation is 30 for the base plus 6 for each byte. So, say there's 32 bytes, for an ERC20 token deposit, we're looking at a gas cost around, 222, which, is not substantially high. And, it's already, Kekek already happens when using a mapping. So, from my perspective, I think the gas cost here is quite marginal.
So just trying to look back through the code and think this through. Does this also mean that every single time you mow, you have to put in this info? Because now we're not storing... I guess that's not the case, because as long as we keep mow statuses, then we know the last time that a user mowed. And so we just need to know the difference between the current grown stock index and the previous one at which they mowed. So yeah, I guess that will work out just fine too.
Awesome. There's also, it's just worth bringing up the point in which, we could go with the concatenation strategy without the hash for just ERC20 tokens. And then when 1155 and 721 tokens are added, those deposits have hashed IDs. But think by doing that, Beanstalk is now operating in some space where it has two different token ID systems depending on what type of token the deposit corresponds to, which might get quite confusing and feel a little janky. I guess anyone have thoughts on that, or does it feel like it makes sense to use kind of the same hashing system for all types of deposits.
So what would you take the hash of for a pods deposit?
Or the so yeah, I mean, if it's like for the ERC20 deposits, which are currently the only ones supported, say we shrink the grown stock index to like a uint 96, such that it's only 12 bytes. A token address is 20 bytes. So what this means is that the token ID can now be the concatenation of the 20 bytes of the address and the 12 bytes of the grown stock index and still be 32 bytes long. So kind of that could just be the ID instead of having to go ahead and hash that. Now, when introducing other value standards, 721 and 1155, into the context of depositing that into the silo, now the domain space extends to 64 bytes because there is now also a token ID associated with that deposit. You deposit, NFT with this address at this grown stock index with this ID, right?
Yeah, the only clarification would be that the grown stock index is an int instead of unsigned int, so I guess that shortens the total amount of grown stock it can be, but it should still be enough room to account for future Beanstalk growth.
Totally. Good point. Yeah, I mean, like from I think like some of the preliminary discussions around this, it seemed like the general consensus was to use a single, use the hashing methodology so that it's future proof. And personally think the implications of doing so are quite minimal. As stated, like it seems like on the contract side, it's only a couple hundred gas to perform the hash operation. From the metadata side, I guess is where it's going to get a little bit more tricky. Where I mean, to some degree, imagine that, like for instance, something like because also with the 1155 standard comes this notion of like being able to actually query the metadata, and that metadata. And I guess it introduces the round, it brings up the question of should that metadata be stored on chain, such that when OpenSea, there's like this function, this URI function. Gonna pull the standard back up real quick here, but kind of there's this URI function that given a token ID. Let me quickly find it. Yeah, so the URI, this URI function, which basically, like for instance, this URI function returns some sort of string, which is some sort of URI that can where when accessed returns some sort of JSON which specifies the metadata for the token ID. And when you go on OpenSea, say you go to OpenSea, you bring up the BNFT Genesis collection, you click on one, you see they have all these attributes. This one that I just pulled up has a background light yellow, body, coffee, halo, wreath. All of these attributes are returned by the URI function on the NFT contract. So the NFT contract, or this URI function, is how clients and user interfaces access the metadata related to this item. In the case of deposits, kind of token address, grown stock index, token ID should probably be attributes of this metadata. Now, recently, as the NFT, kind of ecosystem has developed, there's now numerous ways to actually store metadata on chain. And when thinking from the perspective of the goal is to, maximize decentralization here, an on-chain metadata solution for 1155 deposits should be considered. And, kind of when the OpenSea contract, and I guess there are kind of two options here. Like option one, is like there's some sort of indexer that indexes every new mint token event and every new add deposit event, and kind of stores them, before, listens to them, generates the metadata, stores it on the IPFS somewhere, and somehow updates the URI in the Beanstalk contract to correspond to that metadata that's stored on some decentralized file store. This is less than ideal from a decentralization perspective. However, kind of how important it is to have good censorship resistance around the metadata is unclear, as the metadata can always be, calculated from the actual on-chain events. And it should be quite trivial to verify that metadata is correct. With the replant, it should be noted that kind of the decision to use kind of off-chain metadata for fertilizer was made, and kind of one downstream implication of that is that the metadata is not stored on chain, and think there was one issue that was, or one kind of RFC that was submitted to move fertilizer metadata on chain, which definitely think is a good direction to head in for Beanstalk. However, with deposits, it's a little bit different of a situation where kind of storing this metadata on chain increases the gas cost substantially for all users. So is that substantial increase in gas cost worth that kind of additional ease of being able to fetch the corresponding metadata without having to do event parsing, yourself? So, this is a fairly big consideration. Where if the concatenation method is used, at least just for ERC20 tokens, it kind of kicks the can down the road a little, in a sense that that decision doesn't necessarily need to be made until we get to the point where 1155s and 721s are whitelisted into the silo, by which case, gas fees could be lower. Beanstalk, who knows, might even be migrated to some, ZK rollup with lower gas costs. We might be dealing in a world where at that point, some network native factors have changed, that make it so 20,000 gas cost is pretty, non-significant. So what that means is, like, if it does feel like an important first principle to have this to have all metadata stored on chain for all asset types, it might make sense to use the concatenation method for ERC20 tokens, and only use the hashing method for 1155s and 721 tokens. I guess I'd be curious for the perspective, for some people's thoughts on whether having to, whether using the concatenation method for ERC20 tokens and using the hashing method for 721 and 1155 tokens, assuming it doesn't break the standard, which it doesn't seem to, from a developer experience, does that feel a little bit over the top or ridiculous?
So is the assumption that when a deposit happens, a corresponding event will be emitted with the hash corresponding to that deposit that also includes the inputs that resulted in that hash?
So, looking at the 1155 standard here, there is this, again, gonna have to quickly find it. So the event, they have this transfer signal event. So every time a new deposit is minted, it's required that this transfer single event is admitted. Gonna drop it in Barnyard chat real quick. As you can see, the transfer single event has no space for arbitrary bytes. So the transfer single event, every time, so you deposit beans into the silo. As is currently the case, this add deposit event is emitted, which specifies the token, the grown stock index, the amount, and the user who deposited. With this, with the implementation of 1155, there will probably be some additional event that's also emitted in the form of this transfer signal event from the zero address to the user's wallet with the ID, which is either the concatenated ID or the hashed ID in the value. So there's no way, it doesn't seem like, maybe it might make sense to add the ID to the add deposit event. But the idea is that, there will be some, it'll either be done across two deposits or maybe just one deposit. But, every time a deposit is made, there will be some event that's emitted, which, can be used to define the mapping between token address, kind of grown stock index and the hash.
So worst case scenario, later on down the road, if you only have the hash, all you have to do is parse the blockchain for emitted events that match up with that hash, and you can find all the inputs pretty quickly.
Exactly.
So in that case, it seems like that's fairly decentralized, and you wouldn't necessarily want to waste the extra gas costs to include all of that for every single deposit on chain.
Yes, Pizza Man, I think that's a great point. I agree that, from my perspective, that seems to be appropriate. But there is an argument to be made that, if there is some function on chain, that's a part of the Beanstalk contract that, kind of returns some address, to some like off-chain data store, that might be a problem from a decentralization perspective, but hard to know. I mean, generally, I'm in agreement, that so long as it can be done via some on-chain method, that is sufficient enough. But I'd be curious to know if there's any people who disagree with that general idea.
Can you just restate the trade-off at the margin?
Perspective, P-Man, and in a concatenation method for ERC20 token, hash method for other token types appropriate if that allows us to store the metadata on chain, at least in the short term. As kind of given that the token ID is a concatenation, the token address, and the grown stock index, it can be, from the ID, one can determine what the address is and the grown stock index is by just doing the deconcatenation of the ID.
But in particular, you raise that there may be a problem from a centralization perspective around having or not having the ability to have a function within Beanstalk call something that is on chain and return that data. Is that correct?
Require per year, for the NFTs
It, it,
Can
I don't know if I can't hear you or if I'm having a hard time hearing you. I don't know if that's on your end or my end, but I want to make sure that this is recorded if it's on your end. Can other
It's
people
his end.
hear? Yeah.
Can't hear him.
No, still can't hear you.
Hello.
Yeah,
Yes.
now we can hear you.
All right. Apologies for that. So kind of, the open question is whether the on-chain function that returns the metadata, is properly censorship resistant. In the case where concatenation is used, then it can be on chain for free. In the case where hashing is used, then it's going to cost 20,000 deposit to store on. And the point are only 20,000 gas for first the bit of each token type.
Okay, understood. But just again, now it's a little hard to hear you, although I think we were able to hear that. So the question is whether that's an acceptable gas margin, and also is there an open question as whether that's a required gas cost given the possibility of concatenation?
Well, it's first so there are multiple questions here. Number one is, is it important to have the actual metadata returned by the contract be censorship resistant, given you can always query it through, indexing past events? The second open question is, if the answer to that is no, is 20,000 gas is 20,000 gas a reasonable amount to impose on the user to make that possible? And if the answer to that is no, or some general alternative is it more, is it a better solution to use concatenation for ERC20 tokens, at least now, so that 20,000 gas doesn't have to be imposed in order to make first possible?
How much is 20,000 gas at the moment in dollar terms?
Anyone have a calculator on hand? I think it's normally something like 50 cents to $2, but I don't know right now.
And maybe one other thing to consider is if the inputs for any particular deposit are not immediately accessible through like a solidity function call on chain, then does that limit what kind of protocols can be built on top of this? Or is it safe to assume that any of those protocols that build on top of this can just have a UI that parses the events emitted on chain when they were initially deposited, and then can verify that the inputs match a particular hash, and they can still interact with the data from there? Or is it a requirement that they should be able to read this, the inputs for a deposit on chain?
That's a really good point, Pizza Man. Personally, would have to think about it a little more, and curious for anyone else's thoughts here. But my guess would be that they can index the events off chain, but that's going to be a lot more work and difficult from a developer perspective. To do that. They can also just assume that the non-censorship resistant metadata return from the chain is correct, and maybe that makes it easier. But you are correct in the fact that there will be no function to say, given this ID, give me the token ID and corresponding grown stock per index. With
tools like the graph, is it possible to make like a simple API endpoint that would take in an ID and return the inputs?
Yes. Not sure it would. Yeah, I mean, through GraphQL, there's definitely a way to do that.
You're just talking about taking in like the hashed ID, right? And getting out what was used to make that hash. Because we essentially do that on like pod orders today.
Oh, okay, awesome. Then it sounds like it's pretty doable then.
All right, so we have like 15 minutes left booked for this call. Do we want to talk about like what is the path forward in figuring out the answers to these questions and over what time horizon we need to figure this out in?
Yeah, I mean, from my end, would appreciate some more thoughts, from just, the community over at large, around, what they feel like is appropriate, given the all of the considerations that were mentioned on this call about the different solutions. From my perspective, the most urgent of which is, just to at least decide, whether to change the current indexing method to be a hash. If the decision is made to use concatenation for ERC20 tokens, the switch to the hash structure, it becomes optional. But switching to the hash structure doesn't break anything even if the decision to use concatenation is kept. So perhaps it might make sense to just switch to the hash structure, at the implementation level, and then spend some more time reasoning out, hashing out the different, details of the implementation. I mean, some sort of write up specifying the different pros and cons and alternatives to the different solutions might be helpful to get more community feedback. But that seems my thoughts on. I mean, we appreciate as much different as possible.
Well, so from a timing perspective, could you restate amongst all the open questions that we talked about today, which ones would be like impact Pizza Man's work in the near term? In the very near term?
Yeah, I mean, defer to Pizza Man. From my perspective, changing the indexing structure shouldn't have too many ramifications. But obviously there's potential issues. Kind of what that change would entail is every time a deposit is accessed, to hash the inputs and fetch the value at the hash, and every time it's set to hash the inputs and add to the values at the hash. But Pizza Man's the one who's been hands-on with the new code, so probably he has a better idea. There's also a discussion to be had around kind of the events themselves. The events themselves are, kind of like whether there should be some kind of batch migration at the time of deployment, or if people should individually migrate their deposits and how to do that in a succinct fashion. Might be important. Think adding the full, like, whereas just changing the indexing system should hopefully be a smaller change that shouldn't be too significant. Adding the full 1155 system is definitely going to be, a significant addition to the developer workload. But again, it seems like it's inevitable and, is a prerequisite to get some sort of deposit marketplace online using Seaport. So, from this perspective, it might make sense to just move forward with the full ERC 1155 implementation for deposits as a part of this upgrade. We haven't had a chance to discuss like how migration would occur. Think unfortunately that's kind of downstream of finalizing the implementation. So maybe that's a conversation for a later date. But kind of migrating to this new silo system already gives us kind of a clean cut between pre-upgrade deposits and post-upgrade deposits, and gives us a system by which we can leave the migration of deposits to 1155s from their existing non-standard structure to the users, to where it's like the next time they use a deposit, it will already mint at 1155, and the 1155 balance up function is only going to return the amount that's been transferred to the new system. So from like an elegance perspective, it definitely, personally would prefer to implement them at the same time. But if there is an urgency to get the current silo structure out now, I think at the very minimum changing the indexing system would be beneficial.
I think the only consideration is that there was talk of wanting to release the seeds rebalancing before the release of wells. Is that still a consideration?
Yes.
So I'm not totally sure what all the details are of implementing the 1155 standard, so it's hard for me to say at the moment how much longer that would take me to implement that stuff. At the moment, I'm working on the migrate function, so just kind of to give some color, the first time that you interact with the silo after the grown stock per BDV index change is deployed, you will have to call a special function that will basically migrate your deposits from the old storage system to the new storage system. And in order to do that, you'll have to provide the season of every single deposit that you have, and also the corresponding token that you deposited into the silo. And then basically the on-chain, it will just go through and add up the BDV of all your deposits and verify that the current amount of seeds that you have corresponds with the deposits that you input. And then it will remove your seeds and move all of your deposits over to the new deposit system. And so at the moment, I'm just looking at a couple small rounding issues that I can probably get figured out. But in terms of, what are the other details for implementing 1155, it's not totally clear for me, so it's hard for me to give a timeline on how long that might take.
Yeah, that's a great point, Pizza Man. What the other details are, if you skim through the 1155 contract, the main functions are, kind of balance of, the transfer function, kind of one of, and then some sort of approval system, and then, a batch version of both. The balance of function just needs to take in the index and return the amount at the index. The transfer from function is mostly going to wrap the existing transfer function. Transfer deposits function just have this kind of decoding. We'll need to implement the approval system. The current approval system does not, adhere to the approval system defined in the 1155 specification. And then some, kind of the URI function will need to be implemented. So it is a fairly substantive amount of work. But I mean, one of the main benefits are like this migration function would be the perfect instance for which to just perform some batch mint event, which would just get everything up to par with the current system. So, it seems like some sort of silo migration will be necessary regardless. Some sort of mint migrate function will be necessary regardless when making the change to the 1155s. So it's like, personally just would prefer not to have to do that twice. Just from a complexity perspective, especially if, it seems like it makes sense to move to the 1155 standard sooner rather than later to get that Seaport support. But, it might make sense to just, create some larger documentation around, what's actually required for the standard and, have that discussion on some follow-up call.
So also if 1155 is implemented for deposits, then at the same time, Beanstalk has to decide whether or not it will support pods for 1155 as well. Yeah.
Not quite sure what you mean. Oh, you said as well, not as a well.
Yeah, as well.
I heard as well. I was like, what? I mean, I personally don't think that decision needs to be made at the same time. I think it can be made at a later time. If plots are going to be implemented as a separate contract as 1155, there's zero overlap at all between the two. If they're both going to be implemented as an 1155 within Beanstalk, then it's just going to require updating the transfer from function to include the plot transfer logic as well, and same for the balance of. It probably makes sense to implement them as separate 1155 contracts, and personally leaning towards doing plots as a separate contract and doing Beanstalk as deposits.
Sounds good to me.
Great. So, given that they're probably going to be different contracts, they can be done at different times.
Awesome.
Well, think there are a few. I mean,
be a part of Beanstalk, do they have to be done at the same time?
No, they do not. I'm just kind of there. I guess no, they do not have to be done at the same time.
Is there any condition in which they have to be done at the same time if it's a different contract?
No.
So then they just can be considered independently.
Yes.
So the only thing with a tight timeline is the deposit.
Yes. And the tighter timeline is probably on the indexing system, but yeah. But it would be great to do it all as one.
Including the plots?
Not the plots. Sorry.
What does all as one mean? What is all in this case?
Yeah, apologies. Meaning the whole transformation of deposits into the 1155 standard. Whereas what's discussed really, it would be great to at least use the hashed indexing system. Kind of like at least doing that now, just so that there doesn't need to be a transition to a new indexing system for deposits internally as it relates to the storage. Like at the very minimum, if we change the indexing system to be hashed and then maybe save the deposit ERC20 token actually implementation for later, that is an option as well. So I think at a minimum, migrating the indexing system, at a maximum, doing the whole migration to deposit 1155s.
And so, Pete's man, do you have a sense of how much time that specific piece would take? The part Publius just described about changing the indexing system, apart from the entire migration to 1155s?
I can't say exactly, but it seems very doable. I feel like the scope of that is pretty clearly defined. I don't know what might, there's always something that pops up when you get in the guts of the code and you start changing stuff and you're like, oh shoot, now how am I gonna, make this function work? But I can, keep you guys updated. Or I can tag team it with someone too if there's someone else who would like to help out.
Great. Just wanted to see if that was the question you were answering earlier, or the same one.
Which question was that?
Never mind. All good. I feel like I got all my questions answered on that front. Just that it's not totally clear on timelines for both the entire migration to an 1155 standard and just the minimum work required to change the indexing system to a hash.
Oh yeah, I guess that's a good question. So Publius, do you think that we could deploy the hash system and then tack on 1155 later without requiring another migration?
Yeah, definitely think that is possible. Probably will just be some additional complications revolving, how to handle the migration of existing posits to 1155 tokens. But that can always be handled later. So the overall workload will definitely be higher if it is done separately. But it is an option to just do the indexing system now and hold off on the full implementation for later.
Okay, but it sounds like overall doing the full 1155 now is the way to go.
My perspective, that makes sense, but if the community and the DAO at large feel like there is a little impetus to get moving on this, and maybe adding an extra 1 to 2 weeks of work probably isn't best, then it might make sense to not do the whole system. But from my perspective, doing the whole deposits at 1155s now would be a great milestone to be able to get done. And there is going to be significant overhead with doing it in two separate upgrades.
So we're running over the 2 hours set aside for the call, but perhaps some more discussion is in order to figure out what the timeline would be extended by in both cases. And in neither, I suppose, although that seems like less of an option at this point. So feel free to interrupt me if you think we should keep going on a particular front in this session, but otherwise I think we should probably call it there. All right then. Thanks everyone for coming.